Hi everyone, welcome back to How It's Made. In this episode, I'll be covering my infinite runner game, Dusty Trail. If you didn't play this game or don't remember it, you play as a cowboy going town to town, dodging hazards, animals, and bandits. There's also a shooting mechanic to fend off those said baddies. Let's hit play on the game here just so you can get an idea of the game again. So you pretty much move the horse, the cart follows. The background is scrolling infinitely, and we have objects kind of coming down, and then we can also shoot the snake, and that's pretty much the whole idea of the game. But let me just stop that. But the main focus of the game is actually just having the things scroll and having you spawn random things and then movement. So I thought I would kind of change things up today by, instead of like just going through the few scripts in here, I'm going to start coding it in front of you as well. So let's go ahead and kind of get you a nice basic infinite runner so that it's something that you can build off of once you kind of want to. So I've kind of created a new Unity project here. I just created a new 2D project for this. And I've only added one thing, the demo road. This is just so we can know that our scrolling background is actually working, whereas you have just like squares. You're not really going to be able to see that too well. The first thing that we need to do is actually have our player kind of in the scene and move around. So let's first kind of figure that one out. So let's go ahead and create a 2D object. Use whatever sprite you want. If you have a character sprite, you can do that too. I'm just going to go with a square for now. And I'm just going to call this my player. I usually like to reset the transform to, and then I can kind of start from a 0 spot, which I think I'm going to start from here. And I think for this game, we're just going to make sure our player can only go left and right. We're not going to care about going up and over and all that kind of stuff. So now when we're ready, we can go ahead and create a new C# script. I'm just going to call this one player, and then we'll open it up in Visual Studio. So our player is pretty basic. All we really need to know is like how fast we can go, and that's kind of about it. So just to make this very easy, I'm going to be using public variables for everything. I know that's not maybe the best coding practice, but these public variables allow you to also change the numbers on the fly while in the engine, just looking at the inspector. So that's a lot of the reason why a lot of my stuff's just public, because it's just easier for me to kind of tweak things as I need them without always jumping into the code. Anyways, let's create a public float that is our speed, and we can kind of just leave it at that for right now. So pretty much what we're going to want to do is we're going to want to know when we're going left and right. So we can go ahead and just get some input here. So if our input dot get key, we can actually just use the regular get key, because we'll want it that whenever you're holding it down, you're going to be moving. And we're going to want to use the key code. Let's use A and D to move around. So let's first go with D, because that's going to be in the positive direction. This is moving right. Then there's a few ways you can do it. We're going to do it transform.translate, because I find that this might actually be a little bit simpler for most people to see. So it's going to ask us which way we want to move. So we want to move in a vector 3 or vector 2, and we want to go right. And then we also want to go based on our speed, and we also want to go based on time.delta time, just so we're not going too crazy. Okay, so now we can go right. Let's also go left. So if input dot get key, key code dot A this time, moving left. So then we're going to make our transform dot translate be vector 3 dot left, and then same stuff, speed and time dot delta time. That's pretty much it. We can also kind of, for right now, also put in like a boundary as well, just so that we can't go off the camera screen. So let's also make that while we're in here, float x boundaries. And pretty much all we want to know is that and transform dot position dot x. This is going to be on the right side. We want to make sure it's going to be less than whatever our x boundaries is going to be. And then for our a here, same thing, but the other side, transform dot position dot x. We want to make sure that that is less than, if that is less than our negative x boundaries, then don't go left. So let's go ahead and save that and make sure that it works. So now in our player, we're going to go ahead and add this component. So just drag that script over here onto the add component. Let's give us some speed. Let's do 4. And then let's kind of drag our character over. Maybe I don't want him to go past 6. 6 looks like a good number. And then like -6 over here. So let's go ahead and do that. 6 is going to be our boundary. So now if we hit play, A and D should move us back and forth. So there's D all the way to the end. And I actually went over, so maybe that's not the best way to do it. Let's just move me back. And yeah, now we can go back and forth. There's going to be a quick edit. I just messed this one up here. Make sure that your x position is greater than your negative boundary, obviously. So anyways, now that we know that our player can go back and forth, let me just show you one more time. So we can go all the way to the left, -6 point whatever, and then all the way to the right, 6 point whatever. And you can freely move, which is kind of nice. The next part is going to be to get our road. So what we're going to do is we're just going to drag the road in, maybe kind of place it somewhere near the middle. You can even just make x 0. Something we're going to want to do is, just so that nothing weird happens, we're going to also make sure that our road is going to be a lower order in layer. So maybe we'll make it like -5. That way it's just going to be below our player. And then we're going to also just stretch it a little bit. So I'm going to get this rectangle tool. I'm just going to stretch it out like this. And then maybe like a little bit to the sides too. So now we have some sort of kind of nice looking road. And what I'm also going to do is duplicate this and move it upwards. So this is something important to kind of notice. This is going to be at 0y, and then this one is going to be at 10y as their positions. I know it doesn't match up evenly, but that's okay. So this is kind of something important. We need to know exactly where that position is. So let's go ahead and create a C# script for the road here. Just to make it kind of a broad name, I'm just going to call it our scrolling background. You can also call it maybe scrolling object. That might actually work better. Let's call it scrolling object because we might actually reuse it in a different area. So scrolling object, pretty simple one on this one as well. We kind of really, again, just care about its speed. So let's make a public float for speed. And then we go into the update here, and we're going to use that translate again. We're just going to be moving down. So our transform dot translate, there it is. And again, vector2 or vector3 both work. So we're going to go down by speed, by time, dot delta time. Easy as that. And then the only thing we really care about is once our thing goes off screen, then we're going to want to kind of repop it to the top. So for that, we want to just check to see if our transform dot position dot y is less than or equal to, and then in this case, -10. So if you kind of remember, the position of the top one was at 10. So logically, when it hits -10, it's going to be kind of completely off the screen to the bottom. And so you want to just kind of repop it to +10. So then we just make our transform dot position equal a new vector3. That's going to be whatever our transform dot position is. for the x value, but 10 for the y value. And the z value we don't really care about. And that's pretty much all you need for a scrolling object. So let's go ahead and save that. And then we're going to minimize it. And then I'm going to just attach it to both of my demo roads. I'm going to highlight both, give it that, and it's probably best to give them both the same speed. So let's make that speed like 2. Now if we hit play, you can see they're both going to be coming down, and then this one should pop to the top, just like that. And then we kind of have a very simple thing going on here. Awesome, so now that we have that, let's create some spawners to start spawning some random objects, and then that's kind of all we need to make. So for this, I'm going to create an empty game object, and I'm just going to call this my hazard spawners. And I'm using spawners with a plural because I'm going to make all the actual spawners children of this object. So I'm going to create then another empty game object, and I'm going to call this the spawner. Something I kind of like to do is I always go up to here and give it some sort of gizmo, just so I can kind of see what icon it is. Now I know exactly where it is. I can kind of place maybe a few around here. It's up to you whether you want it to be in the camera scene or, you know, right outside. Probably is a better idea that these spawners are like just outside the camera so that the player doesn't know what's coming for them. It gives them a little bit more of like element of surprise. Anyways, we got our 3 spawners here, so that can be good. We need some sort of prefab though, so that we can actually spawn something. So let's go ahead and create that. So we're going to create a 2D object again, whatever kind of hazard you want. Maybe in this case, let's create a circle. This I'm going to just call hazard. Something I'm going to do, because our scrolling object works so well for this, but I want it to also kind of work for my other objects too. So I'm going to actually reopen the script again. And I'm just going to have a bool here, a public bool called background. So pretty much is if it's a background, do the regular update, otherwise destroy at -10 y position. So that's pretty much like the whole idea for this. So pretty much we can just, in this if statement, if this and background is equal to true, then we're going to do that. Else we can then just destroy the game object. So I think that's a pretty easy way to kind of figure that out. And then when it comes to like maybe you want different things to do different stuff, you can always add tags to them. So we might actually like add a hazard tag to this, but that's fine for now. And then, oh, I already have one on. Let me just remove that. And now I need for the backgrounds to both have background checked on. But now for every other object I create, I don't care, I can ignore this background check pretty much. Anyways, let's have its speed do something like 2 as well. And let's just make sure that it works. So everything disappeared because it didn't meet this this half of the thing. So let's go ahead and fix that up. Let's just make else if transform dot position dot y is less than or equal to, and let's have it a little bit off camera then instead too, since now we can. We're gonna do that, and you want that extra layer of protection, and background is equal to false. As a tip, you don't need this, the double equals to true and false. You can either just like you leave background like that, or you can add the exclamation mark, and that is also false. I like writing them out just so I can see what I'm actually doing in the if statement a little bit better, but it's totally not needed. Anyways, so let's go ahead and try that now. That should work. And nice, here it is. We're gonna move out of the way and we're gonna watch it on the scene. Once it hits like 12, which should be there, okay, it's gone. So there you go, it's gone. Now we're down to the last part. We need to spawn it. So let's go ahead and make this hazard a prefab. And then we don't need it in our scene anymore. So there's a couple of things you can either do. You can either just hide it from the scene like that, or you can actually just delete it. I usually just delete it. Let's create our last script here that we need, which is going to be our object spawner. So we're going to create a C# script, object spawner. For this thing, we need a couple of things this time. So we need to know exactly public game object that we are spawning. So our hazard prefab like that. And then we also want to know about our spawning locations. So maybe a public transform array of spawn points. And then this is up to you. You can either create a float that's going to be a timer, or you can create something that's going to be like do this every certain amount of time, something like that. I typically use the timer route, so I usually make a public float timer, and then in my update I just add time to this timer. Once it hits a time, then do stuff. There's also a way that you can use some other things, but I think we'll go with this way. It's a pretty easy way to kind of handle it. So what you can see here is we then make our timer plus equal time dot delta time. So it's always going to be counting up. Once our timer hits a certain amount of time that we want, so it's greater than or equal to, let's say every 3 seconds. And again, you can make a variable for that number. I'm just not going to. So if our timer is greater than or equal to 3, let's now randomize what spawn point we're going to be using. So we're going to create an int spawn, and that's going to equal random dot range between 0 and however many spawn points we have. So dot length. Once we figure that out, we can then just instantiate or spawn our hazard prefab at our spawn points, whatever thing came out of spawn. And then you also need some sort of rotation, so you can put in transform.rotation as well, or you can use this funny word quaternion.identity. That also works too. And this is complaining because it wants our position. So now we do that. Now the next thing we want to do is just reset our timer. Timer then goes back to equal 0. And that's going to be pretty much the whole object spawner. So let's go ahead and save that and see how it looks. So on our hazard spawner here, we're going to give it the object spawner. We need our prefab, so let's go ahead and drag that in from our assets. Then we need the 3 spawn points, so I'm going to just drag each one in. Boom and boom. And then timer we actually don't really need to care about, so that could have been a private variable if you want, but it's also nice to kind of see it as a debug to kind of see, okay, are these actually spawning every 3 seconds, which there it is. And you can do stuff like this. And yeah, and that's pretty much how you can create an infinite runner. Yeah, so I hope this tutorial kind of helped you in making your own infinite runner. If you'd like to see more tutorials kind of like this, put a comment below, especially if you wanted me to like recreate some of the older how it's made videos, but like this, then again, let me know and I can do that as well. I'm going to be starting a turn-based game next week. So if you'd like to vote on the specific game idea, then follow my Instagram to vote for that. The poll will open later today, probably when this video releases. And other than that, thank you so much for watching, and I'll see you in Monday's video.